Good morning. It's great to be in Lyon for the World Congress. Special thank you to the EPMA and President Ralph Kallstrom for organizing a special event. We've gone through a lot over the past couple of years, but attending conferences continues to move us towards some sense of normalcy by providing us with the opportunity to network and advance the great technologies through the exchange of knowledge and ideas. It is great to see our PM professionals representing every segment of technology gathered under one roof. Parts makers, powder manufacturers, equipment providers, academia, research institutions, and all others. I am pleased to provide an overview of the North American PM industry. My report is based on what was shared earlier this year at PowderMet 2022 and AMPM 2022 in Portland, Oregon. The complete 2022 state of the North American PM industry is available on the MPIF website and in other outlets. The North American PM industry has not been immune from the unprecedented challenges facing the global supply chain. We continue to feel the negative effects of course, COVID-19 pandemic. I don't think anyone could have imagined that 6.5 million lives worldwide would be lost, and let alone over 1 million American lives. The semiconductor microchip processor shortages, resulting in orders being pushed out and even worse, canceled. In July of this year, General Motors reported 95,000 vehicles were unfinished, but in storage because of lacking semiconductor chips. Most automotive companies, whose vehicles use an estimated 100 to 150 processors each, depending on the features of the vehicle, agree that recovery has begun, but a normal supply won't be met until well into 2023. And Volkswagen doesn't expect demands to be met until 2024. The container shortages that has caused difficulty receiving raw materials and shipping finished product to our customers. Earlier this year, the Royal Bank of Canada estimated 1/5 of the global container ship fleet was stuck in congestion at ports. I don't think it is much better today. The Great Resignation, where employees simply quit. In February of this year, a total 345,000 manufacturing jobs. A short-lived record when in March, 360,000 quits. It has gotten better, but still, we have a severe shortage of workers. The unprovoked invasion of Ukraine by Russia had an immediate effect on the availability of raw materials, sending prices skyrocketing, while also causing other global disruptions. Let's not forget about the ongoing electrification of the automobile. America's main consumer of PM parts. All major and minor automotive companies have aggressive plans to discontinue or severely limit the sale of internal combustion engine vehicles by 2030. However, many of these major disruptions should be viewed as opportunities. They have forced companies to work smarter, be more efficient, and innovative. New production output levels are being achieved thanks to changes and innovations made possible because of the pandemic. Many companies report reductions in energy consumption, furnace atmosphere gases, scrap, waste that is sent to landfills, as a direct result of operating more efficiently. Automation with the industry continues to grow as a solution to the overall shortage of workers. From pick-and-place robots at the compacting presses and furnaces to 100% vision systems inspections. Automation will continue to increase. Some companies have replaced older equipment with the latest computer industry controlled in 4.0. This Internet of Things approach allows equipment to talk to each other and learn the best parameters for the process. With nothing on the immediate horizon to reverse the shortage of American workers, we can be grateful that robots usually show up 5 days a week, don't take extended breaks. However, they can be temperamental from time to time. Even with the excessive amount of manufacturing quits during the Great Resignation, the manufacturing sector has proved quite resilient. New factory orders soared over 14% year over year for the first half of 2022. However, the second half of the year is still unknown as inflation has disrupted consumer buying habits. Earlier this year, President Biden and his administration launched Additive Manufacturing Forward. Part of the Bipartisan Innovative Act, AM Forward, is expected to improve competitiveness of America's small and medium-sized manufacturers, creating sustained high-paying jobs and improving supply chain, resilient through adoption and additive manufacturing. Several large, iconic American manufacturers have made voluntary pact to support their US-based small and medium suppliers' adoption of AM. For example, GE Aviation will target small and medium-sized suppliers to compete on 50% of the quotes of products made using AM or related technologies, targeting 30% of its AM parts from US-based suppliers. Siemens Energy will target purchasing 20 to 40% of its AM parts and services from US-based suppliers. Lockheed Martin will conduct research to improve the performance of AM processes as an alternative to castings and forgings. And it will further participate in university and technical college programs for AM workforce development. Honeywell will target US-based suppliers to quote products, machinery, and tooling using AM or related technologies. The continuing acceptance and growth of metal AM has shortened the window from concept to new part launches, and in many cases, combined numerous components into one because of the design freedoms that AM offers. AM is flexible. It can be used as a standalone component production process. It can be used for prototyping during the design process. It can be used to make molds, toolings, and fixtures. It can also be the low-volume precursor solution for a high-volume component produced by another metal forming process like metal injection molding. Speaking of the MIM industry, it continues to be robust, as evidenced by the successful PM2022 conference held earlier this year. Most American MIM parts producers continue to experience double-digit growth. The medical and firearms sector continues to be the prime consumer of MIM components. Even better, the demand for general industrial applications and automotive MIM components continues to increase annually. Improving powder quality will benefit both MIM and AM. A narrow particle size distribution range, greater sphericity, fewer satellites, and less internal porosity will improve throughput, mechanical properties, and overall process consistency. Typically, these powders are manufactured by gas atomization, but capacity has been added recently for plasma atomization, and research continues to develop water atomized low alloy materials for MIM and AM. All of this is positive. The American PM industry is alive and well, landing back on its feet and on its way to recovery. North American iron powder shipments increased 7.8% to 307,105 metric tons in 2021. Historically, iron powder shipments have been the best barometer of the health of our industry, but there will likely be a correction as the automotive industry downsizes engines from 8 cylinders to 4 cylinders. I'll speak to that in a few minutes. The total estimated 2021 North American metal powder shipments increased over 8% to about 360,080 metric tons. Stainless steel, copper, nickel, and aluminum powder shipments all increased by estimated 3 to 11%. Tungsten powder shipments have been strong, readily available for semiconductor microchip processors. These and other powder shipment estimates are detailed in the published report. Powder producers continue to respond to the needs of the industry by developing new and improved materials, additives for conventional press and sinter, MIM, and metal AM. Over the past 2 years, certain well-known dry lubricants have been in limited supply and in high demand, forcing companies to seek alternatives. The demand to improve value-added machining has resulted in new high green strength materials that are suitable for green machining. With the electrification of the automobile increasing, soft magnetic and soft magnetic components are being researched by all major iron powder producers. Most have ongoing collaborative efforts with their customers and academia to identify higher permeability, lower core loss, and increased part strength materials and processes. The Mpif Standards Committee is keeping a keen eye on this development. These magnetic materials have a vital role in the future of electric vehicles, as well as home appliances and other electric devices, and will require standardization. MIM and AM powder producers are seeing strong demands for materials. Generally, the materials of choice are stainless steels and low alloy steels, but there is considerable developmental work being performed on aluminum, titanium, and an array of other metal powders and alloys. Conventional press and sinter parts makers report a continued surge from the industrial sector requiring value-added, near-net shaped parts that have cost-effective lean alloy materials with high material utilization rates. Most have realized increased backlogs month after month. Disrupted supply chains have resulted in the reshoring of some PM parts, but not to the extent that most had hoped for. The general feeling from the conventional press and sinter parts maker is high single-digit to low double-digit growth for non-automotive applications. The current outlook for automotive applications is not as good due to supply chain disruptions. Earlier, I mentioned the importance of iron powder shipments. The iron powder shipments historically has mirrored the automotive industry builds. We estimate over 70% of North American iron powder shipments is used for internal combustion engine automobiles and light trucks. Unfortunately, it appears hybrids have limited use or are not using powder forging connecting rods and PM main bearing caps, large consumers of iron powder. And obviously, electric vehicles don't have connecting rods and main bearing caps. To put things in perspective, there's roughly 9 kilograms of iron powder used for powder forged connecting rods and main bearing caps in an 8-cylinder engine. So as hybrids and electric vehicles gain greater acceptance, we can expect iron powder shipments to decline until other applications pick up volume. Each year we estimate the amount of PM in a North American passenger vehicle. In 2021, there were roughly 15 million vehicles sold, about 500,000 more than 2020, but 2 million less than pre-COVID 2019. Current estimates for 2022 range from 14.2 to 14.7 million passenger vehicles. The semiconductor shortage had a devastating effect on vehicle sales as car lots were empty. The automotive manufacturers diverted the sought-after processors to produce the high-margin large passenger vehicles pickup trucks, and SUVs over the lower margin sedans. This was great news for the PM industry, as the large passenger vehicles consumes an average of 27.2 kilograms per vehicle, followed by the mid-side crossover vehicles at 18.1 kilograms and the sedans at 9 kilograms. Our best estimate for electric vehicles, less the battery, range from 1.8 to 3.6 kilograms of PM. Taking everything into consideration, the estimated average weight in the 2021 North American passenger vehicle remained at 16.8 kilograms. A lot has been made of the doubling of electric vehicle sales in the US to about 800,000 vehicles in 2021 compared with 2020. This represents about 5% of all vehicle sales. Many attribute this electric vehicle increase to the lack of overall vehicles available due to the superconductor shortage. Remember, the North American automotive manufacturer limited small internal combustion engines, sedans, and crossover builds, the types of vehicles targeted by the electric vehicle manufacturers. There are opportunities to introduce the use of powder forged connecting rods and PM main bearing caps in hybrids and new applications in electric vehicles, including multiple speed gearboxes. The superconductor shortage is corrected. As it is corrected, hybrid and electric vehicles gain greater acceptance. The PM weight in passenger vehicles will likely decrease 2 to 3% annually without new applications. But we can't depend solely on the automotive industry. In 2001, Mpif launched the PM Industry Vision and Technology Roadmap. This year, we will release the 4th iteration of the roadmap. If you haven't looked at that landmark 2001 document, lately or ever, one of the 6 priorities identified was focus on emerging product needs that noted reliance on the internal combustion engine is decreasing, and PM producers must develop materials and systems required for emerging fuel cell and hybrid electric vehicle technology. That was over 20 years ago, and we're still talking about it today. The state of California is set to ban the sale of new gas-powered lawn tools starting with model year 2024 and portable generators by 2028. Other states and local governments are considering similar legislation. The lawn and garden sector is a large consumer of PM components in North America. So what now? I believe the North American PM industry will be able to adapt and overcome, but we will need the mindset and resources to adjust to the changing environment. As a global industry, we need to showcase our strengths, work together to advance the technology. We have a lot of advantages over other metal forming technologies. Many companies in our industry have aggressive plans to become carbon neutral sooner than later. Our customers will demand strategies for sustainability and force us to implement sustainability management, carbon reduction strategies, sustainability measuring guidelines for the PM industry. Over the past few years, we've learned about iron powder being used as an energy source, combusting it with hot gases to drive an engine, producing sustainable electricity. We also learned about a sustainable, energy-focused infrastructure for storing zero-emission metal hydride energy. This innovative, safe, and renewable energy storage solution utilizes high-density PM pellets. There are other non-traditional applications for metal powders, including water purification, thermal management, and solar energy. And how about the research to remove oxygen from moon dust? This process byproduct is metal powder that one day could be used to make structures on the moon. These are just a few examples of the creative uses and new opportunities for metal powders. As custodians of the global PM industry, the Asian Powder Metallurgy Association, the European Powder Metallurgy Association, and the Metal Powder Industries Federation continue to advance the PM technology. The collaboration recently supported an updated and more user-friendly global PM property database and continues to support each other in offering the biannual World Congress. Collaboratively, we need to set our sights long-term, not just hitting monthly targets. We need to invest in R&D to create new applications and uses for metal powders and PM parts. We need to work together for a common goal. And let's not forget to attract our future engineers. These students are our future, and we do need to encourage them to get into manufacturing. Mpif has been fortunate to receive supports in the form of conference grants from the U.S. National Science Foundation and Center for Powder Metallurgy Technologies Axel Matson program. To date, 360 grants have been provided to students to further their exposure to the PM technologies. This year, we had 46 future engineers with us in Portland, Oregon. We know that it would be difficult to attract all 46 to the PM industry, but if we could even attract 10%, that's 10% more than we have today. And the other 90%, well, if over their career they are challenged with a problem, and PM is a solution because of what they saw, heard, or learned by attending a PowderMet or AMPM conference, we have still gained another part of application and grown our industry. I've given you some insight into the North American PM industry. We have a lot to look forward to as we advance PM technology. Thank you. Have a great week in Lyon.